We just got done with the stretch reflex and the accompaniment of that gamma motor neuron reflex arc. So now we're going to move into the Golgi tendon reflex. So what is the Golgi tendon reflex? Well, we know we need a stimulus. The stimulus for the stretch reflex was stretch. So the stimulus for the Golgi tendon reflex is contraction, over-contraction of our muscle. So let's go back to our picture of our bicep. And let me clean this up a bit. Okay, so remember, muscles are contractile. Our muscles have these contractile elements to them. So muscles contract, which means muscles shorten and thicken. These tendons that are attaching to the bones, if this muscle is contracting too much, this is going to get overstretched. So let's see what happens. When I contract my bicep, I'm pulling using this tendon that's connecting my muscle to my bone. I'm pulling up on these radius and ulna, causing this flexion, causing my arm to raise. So if I squeeze my bicep so tightly, I can put so much tension on this Golgi tendon that it can stretch and tear and rip. So the whole point of this is that this Golgi tendon now, so instead of in the muscle spindle how we were looking at before, instead of this stuff in the muscle, now we're looking at the tendon outside the muscle. So that's going to be called our Golgi tendon organ. And it's going to detect over-contraction. So let me say contraction of the muscle. And when you over-contract the muscle, you can cause this stretching of the tendon. So stretch reflex, the stimulus is stretch of the muscle. Golgi tendon reflex, you can say the stimulus is over-contraction of the muscle, or you can say the real thing is the stretch of the tendon. But the stretch of the tendon results from this over-contraction of the muscle. All right. How is this going to work? So if we know that we're over-contracting, right? If we're over-contracting, then what is the opposite of contraction? Relaxation. So how this is going to work, we know that we have over-contraction of the muscle. This over-contraction of the muscle is going to lead to relaxation of that muscle. So we already said this Golgi tendon, this thing is going to act as our receptor. So it's detecting the stretch of the tendon. And what is going to end up happening? So if our stimulus is contraction, then to get stretch, you don't have a stimulus that says, hey, you should stretch your muscle. Your muscles contract. Muscles contract. That's all they do. Muscles contract. They shorten and thicken. When you stop sending signals to them, they relax and they stretch. So in order to stop getting this thing to contract and it needs to relax and stretch a little bit, it's going to result in stopping signals to the extrafusal fibers. All right, so stick with me. We have this over-contraction of our muscle, and it's going to lead to relaxation. So we need to stop sending signals to the extrafusal fibers. So let's get a picture of that going. So we know that our extrafusal fibers, we have this efferent fiber, this motor neuron going to our extrafusal fibers, causing it to contract. So the very beginning of this information is we are contracting our muscle. So we're going to take this sensory route from our Golgi tendon saying, hey, we're stretching our tendon too much because of over-contraction of the muscle, and we're going to send it to the spinal cord. Now this time, this Golgi tendon reflex is polysynaptic, which means that we're going to synapse with an inner neuron in the spinal cord. So this is the synapsing with this inner neuron in the posterior horn. And then we know in the anterior horn we have those somatic motor neuron cell bodies. So we'll synapse with an inner neuron to those motor neurons. So I'm going to put some more steps. So let's get some words here. We have this stimulus, this contraction of our muscle. It's increasing, which is causing the stretch. Then number 2, Golgi tendon activates. Number 3, we have these afferent impulses going up to our spinal cord or cerebellum. Since we're talking about spinal reflexes, we're going to keep it in the spinal cord. We're then going to synapse with our inner neuron and then to our motor neuron. And then we're going to have two things happen. So our motor neuron, our agonist is going to be inhibited. So our agonist is our bicep, that main muscle mover. So I'm going to put some X's saying that it's not going to work anymore, which is going to cause this thing to relax. At the same time, we have our antagonist activated. So we have reciprocal activation. What's our reciprocal antagonist here? That's our tricep. So our tricep would contract in this point. So this is called reciprocal activation. So with the stretch reflex, keep these things separate in your head. With the stretch reflex, we have reciprocal inhibition, where the antagonist is inhibited. For our Golgi Tendon Reflex, we have our agonist inhibited and our antagonist activated. So this time we get reciprocal activation. All right.